Thank you for joining us for an introduction of the Intercalc column programs. There's a capability in this software to design concrete, steel, timber, and masonry columns. So let's load up a calculation here real quick. We'll just pick a steel column calculation because we're not really looking at the individual materials, but more the general layout of the column program. You can see here that you can basically use these buttons to change the material that you're using for a particular column design. Let's say you have started off with a steel column and you want to go to concrete. Just select the button and it'll change the material over. We'll go back to steel. In the column program we have several tabs across the top. The general tab always has the different materials here that you can move between, and we'll always have a selection of rotational end fixities for the column. The column program, to the exception of masonry, are all biaxial bending programs, and these end fixities apply to both bending about both axes at the end of the column. And typically over on the right hand side here we will provide the column height will always be here, but you'll always be able to specify your design stresses. This is steel, so you have a selection between AST and LRFD design, and be able to select a database of the various steel grades that you can use. Column sizing, steel of course is very simple. We're just using the AISC database of tables, and we provide you two ways of specifying those sections. First, press the database button that gives you access to our complete database of sections, where you can just scroll and select the section, or you can select a steel section over here on our quick list, and it'll import the section immediately and perform a recalculation of the data. The loading tab. The loading is very flexible on columns. You can have axial loads and lateral loads on the column. And what we do is we're going to be building a table of loads here and that you can use. So first of all, we already have the first line entered, so we'll just call this top floor load, and let's maybe say 1 kip for that, 2 kips for that. We can choose whether or not to include the self weight of the column. And then for this axial load, we can specify an eccentricity about each axis. It's very important that you know the orientation of the X and Y axes. And these call-outs are according to the cross-sectional X and Y axis reference of the column. For steel columns, X-axes are parallel to the flanges of a Y flange. The Y-axis is parallel to the web. So an X-axis eccentricity moves the load out away from the web along the X-axis, which is parallel to the flange of the beam. Let's show you this way. We're going to use a 12-inch eccentricity of the load. Notice how it moves it out along the X-axis. And likewise, a Y eccentricity. Y is parallel to the web. It's up here. And what we'll do for we also have the ability to add the loads at any height along a column. And so this makes it very easy to do multi-story columns. Here you show the representation of the load at the top of the column. You can also put it halfway up the column. And that's true. All these values apply to this one axial load we've entered. If we add another load, let's just say we have a 2 kip load at half the column height. You'll notice we have a column here, an eccentric axial load at the top of the column, and we have a uniaxial load halfway up. So we have very flexible loading capability for axial loads on columns. In terms of lateral loads, you have You can apply a lateral uniform load, partial uniform lateral load, a point load, or a moment. So let's start off with a simple uniform load of 100 pounds a foot laterally. You'll notice it applies it, and it'll apply it along the x-axis or the y-axis. And what we mean here is that this load is being applied laterally to the column the full height to create a moment about the x-axis. And so that is, this load is creating a moment about the x-axis. The x-axis is parallel to the flanges, and so that is going to create tension and compression in the flanges. A y-y load will bend the column, creating a higher and lower tension and compression at the tips of the flanges. And of course you can have a partial length load from maybe 2 to 4 feet. So we have very flexible loading conditions here on the column, both lateral loads and axial loads. As regards to load combinations, of course we always load in the standard ASCE load combinations. And for all the loads applied, it will run a full analysis for each load combination on this column. It'll perform a very detailed analysis. When it's done, it'll give you a summary for each load combination, the maximum stress ratios, and at what location on the column that stress ratio exists for both bending, axial plus bending, and shear. We have another tab here with the detailed values, and I might mention for the column program, this area is quite extensive because it gives capacities for all rotation angles of a concrete column, and the full interaction data for a three-dimensional three-dimensional capacity surface of the column. We're using ASD here, so we have our ASD results. If we went over to LRFD, it would immediately change to the LRFD combinations. So these are the stress combinations and results here. You can see we have moment results about the x-axis and the y-axis, and we have shear results about the y-axis and x-axis. Unbraced length, code formula references here for what's calculating the allowable values, and we have not specified an unbraced length, so these columns are empty, and then we have a bending value there. Deflections, these are the deflections in each direction along the column. You can see here for the various portions of the height we have deflections along the x-axis because we have applied a lateral load for bending about the x-axis. And finally, the reactions of the column, the XX and YY reactions of the column are actually the lateral load reactions about each axis due to the lateral loads. We have a sketch, of course, and then we have a diagram. We have interaction diagrams for the column, for the capacities rotated at any angle, and of course the basic shear moment deflection diagrams. This here is at the top of the column. We have a spike up in the moment due to the applied axial load at an eccentricity. Comes down, is reversed by the lateral loads, and then back to zero. So quite a bit of data in this program. We have a little load reference guide up here, so just in case you forget which direction is which and where the various measurements are, you can refer to that. And of course, load combination tab is typical. Gives you the ability to automatically reverse wind and seismic loads, use additional load factors, etc. So that's a general layout of the column program. Again, you can easily push these buttons to switch between any material you like. If you start out with wood and the loads are just too high, you can easily switch over to steel. We have end conditions, stress specification here, column size data, which will be very different for each program you're using. The loading data is similar for all materials. The slenderness we're going to go through in a separate video. You can establish slenderness for each axis and load combinations. So that's just a quick overview of the column program. And please also see the 4 other videos that we're going to prepare for steel columns, concrete, wood, and masonry columns. Thanks for tuning in.